In the previous video, we began looking at how we can use the tile pattern node to make interesting patterned effects. So we looked at a basic brick wall in the last part, but we're going to start looking at how we can actually utilize the tools at our disposal to work with our tiles in more interesting manners. So what we're going to do in this part is create a tool that can separate out different sized pieces of our tiles and apply different colors to them. The intention here is to firstly show you how we can do things like analysis of a particular image or tile. Secondly, we're looking at how we can actually combine that to create a tool, and then we're going to be creating an interesting mosaic as a final product. So to begin with, we can create a geometry node. We can just call this mosaic gen, dive inside, create a copnet, make sure it's the new copnet, so just the copnet node. We can call this mosaic cop and dive inside. Okay, first things first, let's begin with a tile pattern. So just a tile pattern over here. Now by default, all of these squares or tiles are exactly the same size. If we were to change this to something like an American bond, you'll see that there are smaller tiles and there are bigger tiles. Now, how would we go about figuring out which are smaller tiles and which are bigger tiles? Well, there's going to be a couple of steps to doing this, and we're going to be using the ID for it. So if we take a look at our ID, each tile has its own unique ID. And what we can do with this is we can start doing analysis by ID. So if we go over here and just say ID, you'll see this one over here, statistics by ID. If we set our display flag on this, you'll see that those smaller tiles are a darker gray than the bigger ones. All this is doing is it's measuring the area of a particular tile, and it's doing this per ID. Now, if we take a look at this, each tile is generated by connectivity. So if we get the area of each one of these, it's going to help us find which ones are smaller and which ones are bigger because the ID is limited to connectivity. So back over here, statistics by ID. Let's see what we can do with this. The first thing that we're going to do, and this is just because of a particular issue that you may have, and I'm going to show you this by increasing the inset over here, you'll see that the connecting piece ends up having the biggest area. As we push this up, you'll notice it even more. Now, because this is a single interconnected piece, it's going to almost always end up with the highest area. Now, a way that we can get rid of that is by using a clamp node. And on this clamp node, let's replace with black and then find the upper limit where it starts to cut that out. Right, so right over there, it cuts it out, and this is what we want. So we don't actually want this over here, the grouting or whatever you want to call it. We don't want that to be the highest area, so we cut it out with a clamp. Now, what we can do is with the rest of the results, we can equalize it so that it falls within a usable range, and we can leave it with stretch to black and white. Now we're going to use another clamp node, and this one is going to allow us to narrow in on particular areas. So if I reduce the upper limit, and once again set this clamped to replace with black, you'll see that we can isolate just those tiles over there. Or if we push up the upper limit and then increase the lower limit, we can cut those out. All that means is that we can now create two masks. We can create one where we have this and one where we have this. And then we can give them two different colors, right? So we'll cut out the bigger ones. So we just have this. Now this isn't going to be a good mask because these are gray. Now an easy way to output this as pure white is to just use a threshold, plug this in, and we're just going to drop the threshold to 0. So if the color is greater than 0, make it pure white. That's all we're doing here. So now that we have this, it would be useful to actually have it as a tool because we want to use this once and then we want to use it again for the bigger tiles. So let's go ahead and actually convert this to a tool. We click and drag over all of these nodes, and then over in the top right, we can say create subnet from selected. This is just going to create a subnetwork for us with no outputs. We can rename this to area isolate, and let's add an output. So the output type that we want is going to be a mono, and we can call it something like mask, right? So the output is going to be that which is called mask. We dive inside here, and all we have to do is drop an output node. If we drop an output node, it'll give us a connection between the output and the output over here. So we can go inside and connect this up. So now, up at this level, we now have access to this mask output. The cool thing is we can now bring things up from this network, certain parameters, and we can use them at this level. So let's go ahead and do that. We're going to go to the top right where we have this cog. We're going to click on it, say edit parameter interface, drag this over, and then dive inside of this sub network. We're going to go over to our first clamp over here. We're going to take that lower limit and the upper limit and just click on the word lower limit and upper limit and drag them over to the existing parameters. We also want this one that is going in before our equalize, and we only want the upper limit for this one. Now, this is going to have a bit of a naming issue where both of these are just called upper limit. So we can rename the second one to something like grout limit. Apply and accept, and when we go up a level, we now have access to those 3 parameters. You can, of course, make these nicer. You can drag over a folder, put all of these into a folder, call this something like custom palms, apply and accept. And now we have a separate tab at the bottom for all of our custom parameters. So now we can adjust and push up our lower limit and our upper limit and only get those. And now it's working really well. So let's now use this to actually drive a color, and we'll use a constant. Our constant is just going to be a color of our choosing with a signature of RGB. So we can make this something like red, and then all we have to do is multiply these two together. So plug that into your background, your area isolate into your foreground, and we end up with this. Now, because we're going to be reusing this, maybe it's a good idea to put this inside of our network. So we can cut this, dive inside, and move this over to the end, plugging it in over here. But now we only have one output, and that's our mask, and we'd like to keep that. So maybe we go up a level, and instead of calling it mask, we'll call it something like alpha, and then we'll have a new output that we'll add over here called color, and we can make this an RGB output type. Now we go back inside, plug this into our color, and if we go up a level, we now have access to our alpha or our color, right? So we've made our own custom tool that applies a particular color, and the only thing that we now want is to be able to access it up here. So we go back to our edit parameter interface, dive inside, over on color, click and drag color over, put it under your custom palms, apply, accept, jump up a level, and there we go. We can now also choose the color. So this means that all we have to do now is just duplicate this tool over. You can turn it into an HDA, but I'm not really going to go into that in this tutorial. It's basically as simple as just saying create digital asset. There are a few steps to set that up correctly, but really you could go ahead and do it if you wanted. Now over here where we have our lower limit, let's once again drop it, drop the upper limit, and now we've cut that out. Then over here, we can switch this to something like red. And when you want to blend these two together, we can use a blend, plugging this into color, the second one into color, and we only want to apply this where our alpha is. So we plug our alpha into our mask. And now we can change our bricks depending on their area. So this is only choosing our bigger bricks, this is choosing our smaller bricks, and it's working really well. And the cool thing about this is that you can change the pattern and it'll still work. Sometimes it won't work and you'll just have to tweak the lower limits and upper limits for each of these, but most of the time it'll work as is. So let's go ahead and make this a bit more of an interesting pattern. So firstly, we'll change the pattern type to hopscotch. Then under shape class, we'll use a compound shape and we'll go over to fish scale. That gives us a really interesting look. Now you will see that there are extra shapes that are showing up, but if we take a look at our ID, you'll see something interesting. With the ID selected, you'll see that each one of these is considered a single tile. And that's not really going to be what we want if we want to be selecting each element of this to give a different color to. So we can generate our own IDs and we can generate them with connectivity. So we use segment by connectivity, plug this in over here, and we won't go in with our ID, we'll go in with our tiles. And now we have a more unique ID. We then plug this into each one of these, and now we have a lot more control. So let's create more of these, which isolate some smaller areas. So we'll start from smallest and work our way up to biggest. So bring your lower limit all the way down to 0. The upper limit can just be catching these small details like that. Then we'll have our second area isolate over here. That one will be just above 0. So we don't want those. We want things just slightly bigger than that. So something like that. See what we have. Okay, that's looking decent. Duplicate our area isolate, increase the upper limit, increase the lower limit, give it a different color, duplicate it again, increase upper limit, increase lower limit, new color, duplicate again, increase, new color. And now let's just merge them all together. So we're going to use another blend. So blend right here. Foreground being what we want to blend into it, and then bringing the alpha over, doing that again. Foreground being what we want to blend in, and then the alpha for the foreground. One more, alpha and color. And I just made a slight mistake over here. You'll see that this isn't catching the details under these fish scales, and that's simply because I plugged the wrong thing in. So right over here, there we have it. Okay, but one last thing that I want to show you is just when we have these patterns, right? We can actually take this a step further and develop further patterning over and above this. So if we take this one and do connectivity on this, so we'll do another connectivity, so segment by connectivity, taking the alpha, we end up with new IDs. Now we can do a mask, so ID to mask, And this is a really interesting node for keeping particular IDs. With this over here, we can go keep by range. We'll enable start ID. That'll just make the background black. And then we can choose how many of these we want to select. Maybe we want to select every 1 of 4, and then we can choose the type of offset that we have for it. So let's choose every 1 of 6. And with this ID to mask, let's actually utilize this for something else. Perhaps we can use this as a metallics mask. So let's do that. We'll go over here and do a preview material, grabbing our base color, going all the way back to our starting node over here, our tile pattern. We actually just want this to be our height map. So we can grab that, drag it all the way over to your height, set the display flag. It's going to push it out way too much. So go over to your normals and displace, reducing the height scale to 0.01. Something like that. We can then increase the divisions to 500, and these edges are a bit too sharp. So let's make some adjustments to what's coming in over here. A nice thing that we can do is add a reroute node. So on the way to our height, just Alt and click on this particular stream. It'll add a reroute. And after the reroute, we can add some nodes. So let's just go ahead and add a blur. So plug this into our source. And then let's do a minimum between the two. So minimum, that'll reintroduce the very dark areas. But now we also have a bit of a taper that we can play with. I find switching this to box is a little bit nicer for something like tiles. And then we take that into the preview material, and we now have these nicer rounded edges. Okay, let's also grab this ID to mask that we have down here, plugging that into our metalness. So we can go to metalness, something like that. You'll see that some of them are now metal. And then it's just about doing some randomization. So if you don't want to follow along with the rest of this, it's okay. I think this is most of what we'll be doing in this tutorial, but we're just going to reiterate how we can add some detail using things like IDs and masks and all sorts of things. So up here where we have our segment by connectivity, let's grab our ID and we'll do a random mono. This is going to give us a random color per ID, as long as we plug this into the seed value down here. With this, we'll slightly bring up the lower ends and reduce the high ends by quite a lot. And that's because we're going to use this for our roughness, but we're going to mix this with a bit of a scratch texture. So we can create a noise over here, fractal noise. We're going to stretch it. So we're going to use a transform 2D, grab the one, stretch it in a particular direction, reduce the element size, drop another transform 2D right here. We'll rotate this one by 90 degrees, so that one's pointing up, and then use a noise to blend between the two. So we'll use another fractal noise, increasing the element size slightly, increasing the amplitude, decreasing the roughness, and then we can use a blend to blend between these two transform nodes based on this noise as a mask. You can make adjustments to things like contrast, and then that's going to be a decent value to now mix with our random mono. We can use a blend with our random mono as the background and our noise as the foreground, and we can take a look at some of our options. Perhaps an overlay with a reduced amount like that, and perhaps it would be nicer if these were both smaller noises. So because this is a tileable seamless noise, we can go over here with this transform, decreasing the uniform scale, just like that. Take that, and that will be our roughness. And let's take a look at what we have. You'll have some variation in roughness and these fine scratches on your tiles. One more thing that we can do is take another random mono. So we can duplicate this one over, changing its seed value so it's not the same as the other one. And with our base color, let's use a hue saturate value adjust. So HSV adjust, plugging our color into the source and plugging our random mono into the mask, and then making adjustments over here. So let's decrease the value scale, decrease the saturation scale, do a bit of a hue shift, and you may not notice anything, and that's because this random mono has very low values on its float ramp. You can see that's mostly gray, so we can reset this ramp. And now you can see that our variation is working. There we go. Plug that into your base color, and we're basically good to go. We've got a fairly intricate pattern over here that can be applied to something else, like a sphere. And now all that's left is to render it or make further adjustments to this. You can also add noises to your various patterns, or even go back over here and reduce the spacing between these. We can go down, reducing the offset and reducing the thickness of the fish scale. That's going to give us finer lines. We can use a noise pattern in the grouting to add to our bump. So we have this very basic bump over here, but we can use a noise with a high roughness, small element size, using a maximum operation between the two, so that there's a bumpiness in between, also reducing the center and the amplitude like that. Take a look at how that looks. Finally, if you want your grouting to not be shiny like the rest of it, that's very simple. All we have to do is take from here, which is going to be our unblurred tile mask, invert it. That's going to give us white against black. And then where we have our roughness here, we can do a maximum operation between the two, like that. Now our grouting is all rough. The last thing that I want is to just make our grouting white, because I do think that in a lot of mosaics, they don't use black grouting like this. So we can do the same thing, once again, choosing a maximum. So for our base color that's coming in, choose the maximum between these two, and now we'll have this white grout. And then the last thing to do is to just render this. So let's go over to our stage level, scene import. That's going to be a scene import all, comma physical sky, setting up a camera, switching to an XPU render, and making some adjustments to our sky. So increasing the exposure for one. We can also hide our grid, not render light geometry, and make our background dark. And now we can just swing this light around and see what we have. As you can see, we have some of them being metallic. And if you like that effect, it's extremely easy to just apply it everywhere. So we go down to where we have this ID to mask. And all we have to do is take this alpha as our metallic layer. So metalness straight in there. And then perhaps we'd like these to rather be like a rose gold or something. We can easily change our color over here to something like that. Back over here. And of course, there's so many changes that you can make to this. This is the type of thing where you can just play around for ages until you find something that you're happy with. We can do even finer scratches on this. And you can even take these scratches and use them for a normal mask. So if we go over here and create a height to normal, we can grab our roughness, plug it into the height to normal. That gives us that. Plug that into your normals. And over here, all we have to do is go down and reduce the normal map scale to something like 0.01. Something very fine. And now the light actually plays off of it as if it's got that texture. So this is just one of the many ways that we can use cops to create tile-based effects. And I hope that this video helped you. There's a bunch of cool little techniques and things that I figured out while making this, and I'm just happy to share it with everyone. So if you did like this video, please feel free to leave a like, leave a comment. I'll try to get to all of the comments if I can, especially if you're over on the side effects website. And if you haven't already, feel free to join the Houdini Academy Discord. There's a bunch of extremely talented individuals on there. There's a lot of the side effects employees, and you can talk to them directly in the Discord. The community's really picked up recently, and I highly recommend checking it out. So thank you for watching. I'll see you in the next video where we're going to be creating complex patterns with warping UVs. So I'll see you soon for that video. Until then, bye.